second part of our proving trig identities, we're going to talk about the last two identities that are on our entire trig identity sheet, which are product to sum and sum to product. And then we'll also talk more about how we can prove them when I have the left side equal to the right side, so continuing on from yesterday's lesson. Take a moment to pause the video and take a look at the different combinations of sines and cosines being multiplied together, as well as added and subtracted together, and how their signs are the same or similar to on the right and the left hand side, to kind of get an idea of them. Let's look at our first one. It's asking us to find an identity for 2 times sine of 3 theta times cosine of 7 theta. So I'm taking sine times cosine. So I'm going to utilize the third option here since I have sine times cosine, where I'm going to let x be, or a be, the 3 theta, as well as y or b be 7 theta. So wherever I see x or a, or wherever I see y, I will use 7 theta. So here. Okay. This will provide us with, utilizing the identity, we first start off with 2 times, then we'll move into the identity itself, half times sine of 3 theta plus 7 theta plus sine of 3 theta minus 7 theta. If I were to go ahead and multiply, notice I'm taking half times all of this. So when I distribute my 2 in, the only thing I need to distribute that 2 into is that half, and 2 times half ends up being a whole, so it's a moot point. I now have sine of 10 theta, since 3 theta plus 7 theta is 10 theta, plus sine of negative 4 theta. At this point, we can use our even and odd identities on the top of our identity sheet to give us sine of 10 theta minus sine of 4 theta. These are not the same, so we cannot combine them together since one is 10 theta and one is 4 theta. So at this point, we are finished. Example 2 is asking us to find an identity for sine of 7 theta minus sine of 4 theta. So I'm taking a sine minus a sine. So we're going to use this second option for sum to product, where I'm going to let 7x be my x value and then 4x be the y value when I'm substituting into the identity itself. Utilizing the identity, I'll have 2 times cosine of 7x plus 4x over 2 times sine of 7x minus 4x over 2. Simplifying inside our parentheses, I'll have 2 times cosine of 11x over 2 times sine of 3x over 2. And at this point, we're finished. There's nothing else that we can do to combine together. This next example, we have cosine theta minus cosine of 7 theta. So we have cosine minus cosine. So I'll use theta as my x value and 7 theta as my y value. And utilizing the bottom sum to product identity, we'll have negative 2 times sine of theta plus 7 theta over 2 times sine of theta minus 7 theta over 2. I'll have negative 2 times sine of 8 theta over 2, which simplifies to 4 theta. And theta minus 7 theta gives me negative 6 over 2. So negative 3 theta. I'll want to use my even-odd identity here to eliminate that negative inside our parentheses. And with this negative on the inside and this negative on the outside, utilizing that even and odd identity, that negative pulls out to the front. So a negative times a negative will then turn us into a positive 2 times sine of 4 theta times sine of 3 theta. And at this point, we'll be done with this particular problem since we can't combine them together. A few more examples. Find an identity for 2 times 7 of theta times cosine of 3 theta. This is very similar to problem number 1 on the front page. So pause the video and see if you can't complete this one on your own. I'll first start off by taking 2 times the identity itself, which is 1/2, times sine of adding them together, so 7 theta plus 3 theta. You can do some of these in your head. You don't have to write all these steps down if you don't need to. So again, I'm taking 1/2 times all of this stuff here. So when I distribute the 2 through, the only thing I need to distribute is 2 with the 1/2, which simplifies to 1. Now I'll have sine of 10 theta plus sine of 4 theta. And we can't combine them together because their thetas are not equivalent, so we will be done. In example 5, we have cosine times sine. So we're going to use the product to sum identity. So we'll take 1/2 times sine of 2t plus t minus sine of 2t minus t. That 1/2 will stay here since we don't have anything on the outside to multiply with it. But then sine of 3t minus sine of t. You could distribute the 1/2 through if you'd want to, but at this point we can stop. Pause the video and try example number 6 to find an identity for 7 times cosine of 5 theta times cosine of 7 theta. When I have cosine times cosine. We will then have 7 times 1/2 of cosine of 5 theta minus 7 theta plus cosine of 5 theta plus 7 theta. Again, I'm taking 1/2 times all of this, so when I distribute my 7 in, I'll still have 7/2 times cosine of negative 2 theta plus cosine of 12 theta. I need to use my even and odd identity to eliminate this negative. And with cosine of negative 2 theta using even odd identity, it just simply turns into a positive value. So cosine of 2 theta plus cosine of 12 theta, and we're done. We have cosine of theta plus cosine of 5 theta. So we're going to use our sum to product identity. We'll use our third option down when I'm adding 2 cosines together. So 2 times cosine of theta plus 5 theta over 2 times cosine of theta minus 5 theta over 2. Or 2 times cosine of 3 theta times cosine of negative 2 theta. Using our even and odd identity, when I have a negative value, using the even and odd identity just becomes positive. So 2 times cosine of 3 theta times cosine of 2 theta. I'm going to put this next problem on the next page for us, since we'll run out of room, where we're going to prove the identity of tangent of 2x times cosine of x plus cosine of 3x. Prove that that's equal to sine of x plus sine of 3x. So we're going to be able to utilize our even and our sum to product pieces. What I'm first going to do is turn tangent. I'm going to start on the left side and see what we come up with. We might need to move to the right side. We'll see what happens here. I'm going to move tangent into sines and cosines and then use the sum to product identity for a cosine plus cosine. This will then give me on the left-hand side sine of 2x over cosine of 2x times, so utilizing the sum to product of a cosine plus cosine, I'll use the third option down on our identity. So 2 times cosine of x plus 3x over 2 times cosine of x minus 3x over 2. I'll still have sine of 2x over cosine of 2x times 2 times cosine of 2x, since x plus 3x would be 4x, divided by 2 would be 2x, times cosine of negative x, since we'll have negative 2 over 2, which is negative 1. Utilizing our even and odd identity, we now have sine of 2x over cosine of 2x times 2 times cosine of 2x times cosine of regular x, utilizing our even and odd identity for cosine of negative x. Notice now we're all in multiplication here, and we do have a common factor. I have a common factor of cosine of 2x in our numerator and denominator. This then will simplify to 2 times sine of 2x times cosine of x. And at this point, there's not a whole lot we can do. So let's move to the right-hand side, sine x plus sine of 3x, and see if we can't get that to equal the left-hand side. Now, you could utilize on the left, maybe you want to break this into from product to sum. You could certainly do so, and perhaps you'd come up with the same idea. You just might have to get a little creative in order to get the sine of x plus sine of 3x. But let's tackle the right-hand side. So we are adding 2 sines together, which means that I'm going to use the sum to product of sine plus sine, so the top option. So this will give me 2 times sine of x plus 3x over 2 times cosine of x minus 3x over 2. Simplifying, we'll have 2 times sine of 2x times cosine of negative x. Utilizing the even and odd rules, we'll have 2 times sine of 2x times cosine of x. And now I have the left-hand side equal to the right-hand side. And so we know we have done and proved this. Let's move to example 9. I've got the tangent of x plus y over 2 equal to sine of x plus sine of y over cosine of x plus cosine of y. In this particular example, notice that in our numerator and in our denominator, we have, we're adding 2 sines or adding 2 cosines. Perhaps we could start here. I don't have a tangent value for sum to product. So let's start on the right since it obviously looks a little bit more complicated. And we'll move them to sums to products. Looking at our numerator, we will have 2 times sine of x plus y over 2 times cosine of x minus y over 2 all over 2 times cosine of x plus y over 2 times cosine of x minus y over 2. A couple of things are happening. Notice that these are all being multiplied together, so we have some common factors that we can eliminate. I can eliminate 2 because they're a common factor. And notice here on the right, we have cosine of x minus y over 2 times over cosine of x minus y over 2. So we have a common factor here. What we cannot do is say, well, hey, here's x plus y over 2 and an x plus y over 2. We cannot do that because they're attached to sine and cosine, right? They're not the exact same. But what I do now have is sine of x plus y over 2 over cosine of x plus y over 2. And we know that sine over cosine is tangent. So this will lead me to tangent of x plus y over 2. And the last example, we want to prove that the tangent of x plus y over 2 times tangent of y minus x over 2 is equal to the right-hand side where we're subtracting cosine and we're adding cosine. What I'm going to start off by doing is looking at the right-hand side, similar to what I did in example 9, utilize our sum to product identities where we're adding and subtracting cosine. So let's start with that. In our numerator, we will end up with a negative 2 times sine of x plus y over 2 times sine of x minus y over 2 all over. Looking at the addition of 2 cosines, we'll have 2 times cosine of x plus y over 2 times cosine of x minus y over 2. I have a couple common factors here, my 2's to be exact. And then notice I have sine over cosine with the exact same value, and then sine over cosine with x minus y over 2. That now allows us to have negative, we still have the negative from here. So negative tangent of x plus y over 2 times tangent of x minus y over 2. So we're almost there. We have tangent of x plus y over 2, but we don't have tangent of y minus x. These are not the same. These are not the same. If I were to rewrite this, it would be negative y plus x. But what I can do is factor out a negative 1 so that I would have we would have y minus x, still over 2, and utilizing our even and odd identity, this negative would pull out front. So when I combine these two negatives together, utilizing our even and odd identity, that negative would pull out front, which would give me then tangent of x plus y over 2 times tangent of y minus x over 2. So by utilizing the even and odd and rewriting that tangent on the right-hand side, pairing it with the negative with the tangent on the outside also gets rid of that negative because it's wanting us to be positive here. And that takes care of all of our trig identities that we have learned and proving them, but there's much more to come in lesson